Welcome to my class. I'm going to handle the scientific computing using Python for this semester. The subject code 18 UECE 512. It's a 3 credit. Per week we have a 3 hours class. About me, you might have heard my name. Myself, Dr. S. Vivaraktimat. I've done JTS, Diploma B, MTech and PhD. And more than 60 publications I had done with my students. And as an administrator also I have served this institution as a sports advisor, a PG coordinator, secretary of IT Subcenter Dharwad, chairman of IT Subcenter Dharwad, coordinator of Bosch Rexroth Center of Excellence, SDMCT Dharwad. Experience: I served in the industry in the beginning. Then I joined Anjuman Engineering College Bhatkar, then Tontar College of Engineering Gadag. Since 2004 I am serving in this SDM College of Engineering Technology. The course learning objectives. The course focuses on programming concepts in Python. It includes basic numerical algorithms covering interpolation, integration, differentiation, ordinary differential equations and partial differential equation solvers, and basic linear algebra. So course objectives: examine the Python syntax and semantics and use the Python flow control and functions. Like that we have CO2, we have CO3, CO4 and CO5 to solve the integration and ordinary differential equations and perform interpolation. The content, the syllabus, we have Unit 1, the core Python language, 8 hours, and Unit 2, a simple plotting with a Pylab, and the core Python language 2. These are the chapters we have. Total 8 hours is allocated for Unit 2. Unit 3 we have an NumPy 1, 7 hours allocated for this, and Unit 4 NumPy 2. There we have a matplotlib also. The total hours allocated for the Unit 4 is 9 hours. Unit 5 we have SciPy. There we are going to discuss about integration, definite integrals of a single variable, integrals of a 2 or more variables. And coming to the reference books, we have these reference books, but most of the time we are going to use Christian Hill, Learning Scientific Programming with Python. This either you can purchase or you can try to get an ebook. This is a book, how it looks. On Python, it is devised by this person, Van Rossum, in 1989. And he born in 31st January 1956. His age maybe 64 years. Nationality is a Dutch. And education, he is from University of Amsterdam in 1982. Python is a higher level than C. Reason is it has a variety of data structures such as list, tuples, sets and dictionaries. And a person who has developed this was a fan of the show BBC comedy series from the 70s, Monty Python's Flying Circus. Because of this, he kept the name of the language as a Python. On prerequisite, no need to know the coding compulsorily. If you know a little bit coding, then it will be an advantage. Features of Python programming language. It is readable, easy to learn, free, open source, large standard libraries are available, and memory management, cross-platform. These are the features of a Python programming language. What can you do with the Python? You can use it for web development, in machine learning. Nowadays, we talk more about machine learning, deep learning, artificial intelligence, etc. Python you can use for that. Data analysis. You can use for scripting, game development. We can develop embedded applications in the Python. So these are the points you can say where you can use a Python. The content, the first unit is this. So we'll start with the introduction, the Python shell, numbers, variables, comparisons and logic. Try to see this C program to display the three names. Now I have to include all these standard libraries, stdio.h, stdlib.h, string.h, and I'll define these two. Then I'll write a main program. There I'll declare the array. Then in that matrix I take a name of 0, first name, and later I'll take another name. This is the way how I assign some names to the strcpy. Then in the looping I will display the names. So this is a complete C program to display three names. Now how I can do it in the Python? Simply I'll write names equal to three names. You can write whichever name you want. This is from textbook I have taken. You can write your names only. And write down next line for name in names colon print name. These three names will be displayed. You just compare how many lines I write a C program, how many lines I write in case of Python, and which is easy, which will take more time to write a code. In case of C coding, overhead is more. You can just see these two programs. One is in Python and there is a C language. All of you know, or you might have heard already many times, the compiler, and another name is a interpreter. Try to recall what's the compiler? Yeah, try to recall. Interpreter? Yeah. Okay, let us see. A compiler is a program which converts the entire source code of a programming language into executable machine code for the CPU. Can you give some examples? C, C++, Java is correct. Interpreter takes a source program and runs it line by line, translating each line as it comes to it. This is a compiler and interpreter one should know. Can you give the example for a interpreter? We have JavaScript, Python, Perl. So these are some of the examples for an interpreter. You may get a one word in the textbook, bytecode, whenever we talk about a Python. It is between the program and a machine code. Python first compiles it into a bytecode. The bytecode is sent to for the execution to the Python virtual machine. The Python virtual machine is the interpreter that runs the bytecode and is a part of the Python system. Python syntax philosophy is what? There should be one and preferably only one obvious way to do it. Why they say this? For example, if you take a Perl language, there are different ways to output a list of names. But in Python, we have one way. But in Perl, many are there. There is a way why they say this particular one line. Advantages of the Python is a high level language, very plain and simple syntax, is free and open, cross platform support, You can do it on Windows, Unix, Linux, Mac OS. You can use in different operating systems. Large library of models and packages that extend the functionality, NumPy, SciPy, Matplotlib, and relatively easy to learn compared to any other language. Python is easy, you remember. Python is flexible language and best features of a procedure is available in case of Python. Object-oriented programming concept, what you know, all those are available in case of your Python. And functional, all these are available in the Python, that's why it's called as multi-paradigm. And it's dynamically typed and speed of the development, less time to write and debug a Python compared to other C, C++ or Java. Disadvantage, slow speed because it's an interpreter. Python speed is less than C, Fortran, and not memory is utilized efficiently. It uses a large amount of memory. Weak in mobile computing. It's good for server, not for the client. Runtime errors. Same variable once you can use as an integer, later you can use as a character. Hard to hide the source code. Compatibility issues between the compatibility, especially in Python 2 and Python 3. And remember, we are going to use Python 3 only. Python 3 is not backward compatible, but remember we use a Python 3. Don't try to execute any code related to the Python 2 in the Python 3. To install the Python, you can use the link www.python.org, which contains a full and easy to follow instructions for downloading the Python. Anaconda is available freely. This is a website how it looks. You can download. And for Anaconda you can use this link. And for NumPy, Matplotlib, SciPy, IPython, you can use these links. And you can install in your computers. If you don't want to install anything, you can use the online Python compilers. Many are there. Few I have listed here. Even you can simply Google it. Online Python compilers, you'll get many. Without installation, you can execute in the beginning some programs. Either you can take a snapshot of this, or you can note down at least one or two, so that you can execute the Python programs. The core Python language, the Python shell, what we call as a prompt. So this is what we use, 3 chevrons, where you can enter the Python commands. So unit 1, now we are discussing. Let us go to the numbers, variables, comparisons and logic. Types of numbers in the Python, we have integer, floating point numbers, we have a complex numbers. The Python supports all these three. Integers you have studied already in C language. 1, for example, 8 minus 72, and another integer number. There is no limit to the magnitude. So one important point which you have to remember. And integer arithmetic is exact. Most of the things you may be knowing, it may be just a revision. Floating point numbers, these are real numbers such as 1.2 minus 0.36 and 1.67263 into 10 raised to minus 7. They represent but are stored in the binary to a certain precision. This is very important. One line you have to understand. For example, 4 by 3, you will get 1.33333. There is no end, infinity. You may get sometimes in some of the cases. A Python floating point numbers, examples are shown here. 2.0, 1.23 e raised to 4, capital E also you can use, lowercase also you can use, 5.678 e raised to minus 4. In complex numbers, Python supports complex numbers also, but denoted by J. Real and imaginary numbers represented as a floating point number. Complex number arithmetic is therefore not exact. Some examples are written complex number 2.3 plus 1.2j, or another way how we can write is complex, the same thing 2.3 comma 1.2. Just read it once, go through it once. Typing a number at the Python shell. For example, if I type 5 in the Python prompt, I'll get a 5. If I type a 5 point, nothing else, if I put an enter key, what I'll get? You should practice. I'll get a 5.0. If I type 0.10, what I'll get? 0.10. Yes, I'll get a 0.10. 0 will not come. Try all these things. If I type 0.0001, what I'll get? 0.0001 only. If I type 0.000999, what will get the answer? Same, huh? I'll get 9.99 e raised to minus 0.5. Try to read this. Python interpreter displays the number in a standard way. The internal representation of 0.1 discussed earlier is rounded to 0.1, which is the shortest number with a representation. And numbers smaller in magnitude than 0.0001 are displayed in scientific notation. Because this number was 0.0001, it is displayed as it is. When I say 0.0000999, it is less than 0.0001, hence it is displayed in scientific notation. You can pause the video, rewind the video, try to understand, and you have to practice these things. By just seeing the slide, it is difficult to remember. If I type a float of 5, if I put an enter key, I'll get a 5.0. Int 5.2, if I type this, if I put an enter key, what I'll get? 5.2. When I say int, I'll get an integer version of that. 5 I'll get. If I type of int 5.9, what I'll get the answer? I'll get 5 only. If I write a complex 3.0, what I'll get? I'll get 3 plus 0j. If I type complex 0 point, comma 3 point, I'll get the answer 3j. Now try to read this and understand. The first case, Note that a floating point number is rounded down in casting it into an integer. You have 5.9 becomes 5. Second case. Constructing a complex object from a float generates a complex number with an imaginary part equal to 0. This you can observe. 3 plus 0 is 8. When I say complex of 3 points. Third, to generate a pure imaginary number, you have to explicitly pass two numbers to a complex with the first real part equal to 0. Try to type like this in front of the Python shell prompt. Try to observe the output, understand. So far we have discussed types of numbers in the Python, integers, floating point numbers, and one more is complex numbers. You can pause the video, try to recall what all we have discussed. If you won't get anything, just rewind this video, see it again. Once if you feel comfortable whatever I discussed so far, then you can continue the later part of this video. Basic Python arithmetic operators. We have addition, subtraction, multiplication, floating point division. It's very important. We have a integer division. And modulus, exponential. Most of the things you know, but these two are very important. Python has two types of division which you have to remember. Floating point division, always written as floating. Integer division always rounds down the result. Read it twice, remember it. Addition, subtraction, multiplication is same as what you have studied so far, but division we have a 2. For example, 2.7 divided by 2 if I do, what will be the answer? I'll get 1.35. If I divide 9 by 2, what I'll get? 4.5. If I divide 8 by 4, what I'll get? 2.0. If I divide using like 2 slash, it will do the integer arithmetic and it will be rounding down. For example, 8 integer division, 8 integer division the 4, I'll get a 2. 9 integer division, I am doing it 2, 9 by 2. What's the answer? I'll get 4. Similarly, 2.7 by 2 integer division, I'll get 1.0. You can pause the video, go through the basic Python arithmetic operators, especially floating point division and integer division. These are the samples executed program showing you. Print 2.7, what you have done, the same program, same instructions are written. Instead of writing in front of the Python shell prompt, simply I am writing a print instruction. Print means you will get the answer on the screen. For example, print 2.7 by 2, I will get 1.35. So these things we have discussed so far. The same thing I have executed. You can try to understand this program what I have written, step by instructions and the answers what you have discussed, what I got in the simulator. Pause the video, practice this integer division and floating division. The modulus operator, 9% is 2, the answer will get 1. The 4.5% is 3, or you can say the modulus 3, the answer is 1.5. The simulated result also you can observe. This is what I have written the commands. Many simulators are there online. This is a Python 3 online coding ground. This particular simulator I am using for some time now. Again, the number returned is an integer only if both of the operands are integers. Try to observe. And if one is floating, the answer is floating. This is a 2 plus 4 into 3. Whether is it going to evaluate to the 14 as 2 plus 12, or it will become a 18 as 6 into 3, which is correct. Try to write down some answer in your notebook. Don't listen like a pravachana. Use pen and pencil. You'll see it now. So, Python arithmetic operator precedence. This is having a highest exponential, then multiplication, then lowest precedence is addition and subtraction. The answer is 14 for this particular, because multiplication has a higher precedence than addition and is evaluated first. Therefore, 4 into 3, 12 plus 2 will become answer 14. 2 plus 4 into 3. This precedence rule are overridden by the use of parenthesis. First it will do 2 plus 4, then it will multiply to 3. The answer will become 18. Try to go through. Now it is executed. Observe what I have written instructions and the result also. I got 14 answer when I typed 2 plus 4 into 3. When I wrote 2 plus 4 in the parenthesis into 3, the answer is 18. Operator precedence. Operators of equal precedence are evaluated left to right. This you will be remembering. And with the exception of exponential. 6 slash 2 slash 4. It is same as 3 slash, or you can say 3 by 4. The answer is 0.75. Or you can write 6 divided by 2 divided by 4. This I have taken the parenthesis. It is nothing but 6 divided by 0.5. Answer will be 12.0. These things you can execute and check it. 2 exponential 2 exponential 3. What I will get? I will get 2 exponential 8. The answer will be 256. Similarly for this it will be 64. And throughout our discussion, remember this is a comment. If I write a hash something, in front of hash whatever I write, this is a comment in Python. The same program is executed, and whatever you have discussed so far, the same answer we got. The result is same in the simulator. Try to observe this and try to see this result also. Compare with what you have discussed. You can pause the video, try to understand this. So far, whatever we have discussed, floating point division, always written the floating. Integer division, we have discussed. Modulus operator, we have discussed. And try to understand these things. When I type this answer will be 2. When I type this, I'll get a 1 y. Try to understand this. And the Python arithmetic operator precedence we have discussed. Just read it once, go through, try to understand. You can note down, take a snapshot. And you can pause here and even you can rewind also. Try to understand whatever I have discussed so far before you go to the next. Methods and attributes of a numbers. Python numbers are objects. In fact, everything in the Python is an object and it have certain attributes and which are accessed using a dot notation. For example, 4 plus 5j dot real, you'll get an answer 4.0. 4 plus 5j dot imaginary, you'll get an answer 5. You can call the functions 4 plus 5j dot conjugate, you'll get a 4 minus 5j. Type some digits dot bit length, it will give the number of bits used to represent this particular number, and the empty parentheses indicate that the method is to be called. For example, you are writing a conjugate here, it's an empty parenthesis. Python allocates as much memory as necessary to exactly represent the integer number. Just try to understand, revive whatever you have discussed, try to remember the functions. Now this is the output. When I write print 4 plus 5j dot real, I got 4.0. Whatever you have discussed, the same thing is observed as a result after the simulation. Mathematical functions, we have a absolute function, absolute of minus 5.2, you will get a 5.2, absolute minus 2, we are going to get the answer 2, absolute 3 plus 4j, we are going to get answer 50. The same function we are using, but it behaves differently for depending upon the whatever the parameter we are passing. This is an example of polymorphism. The same function does different things to different objects because these are all objects. If passed a real number x, it returns absolute of x. If non-negative magnitude of the number without regard to sign, if passed a complex number z equal to x plus iy, it returns the modulus. So please try to understand these functions and the meaning of this. Even though the function is same, it does different things to the different object. So this one line you have to remember. The mathematical functions, round function you can use. Round a floating point number to the nearest integer. For example, you have minus 9.62, you will get a minus 10. Round 7.5, you will get a 8. Round 4.5, you will get a 4. And the answers we have here, 7.5 I got 8, 4.5 I got 4. You can do the simulation, try to understand how it behaves. So far we have discussed all these things and go through. When I write print 4 plus 5j dot real, I will get a 4. When I write dot image, I will get a 5.0. When I get a conjugate, I will get a 4 minus 5j. When I say bit length, I will get a total number of bits. And absolute round function we have discussed. Many useful mathematical functions are provided by the math model, which is imported with the statement import math. These are the some functions provided by the math module. So write a program or write a one instruction and try to understand all these things. Now you read one by one, square root, exponential, log, all these things you please read it once, and what it performs function you please try to understand, and write a one instruction and simulate it in the simulator so that you can understand better. One point is angular arguments are assumed to be in radians. Some other functions: cos, tan, sine, so arctan, arccos, whatever these functions are there, you can just simulate and check it. Gamma, degrees, each we cannot discuss each statement in the class, you have to do the simulation. So your work will be more. So these things you have to simulate and you have to check in your computer. Some functions import math when you do it. If you write a math of .exp minus 1.5, the answer will get e raised to minus 1.5 answer will get. Similarly, math.cos of 0 answer will get. Math square root of 16 will get an answer 4.0. The math model also provided two very useful non-function attributes, pi, one more is epsilon, e. E, this will give the value of a pi and e. When we write e raised to, automatically it will take the value of e, and when you say 2 pi, pi value will be taken. When I say import math, I can write cos 180, the answer I will get. And it is the same as from math import, like this also you can write, or you can write like this also. These are the instructions I simulated, result I got like this. Function concatenation also possible. I used a sine, I used here pi, and the same thing I simulated. Just go through once, try to understand. Thanks for watching.